Let us look at another example of cost volume profit analysis. The Maxis Manufacturing Company manufactures and sells pencils. Currently, 5 million units are sold per year at a selling price of $0.5 per unit. The fixed costs are $900,000 per year and the variable costs are $0.3 per unit. Now, we have to compute the new break-even point in terms of units for the following changes. First, a 10% increase in fixed cost, and second, a 10% increase in selling price and a $20,000 increase in fixed cost. So let's say this is the manufacturing facility of Maxis Manufacturing Company, which is in the business of manufacturing pencils. This supplier represents Maxis Manufacturing, and Maxis is selling pencils to the customers. So currently, Maxis Manufacturing is selling 5 million units of pencils per year. And in return, it is getting an amount of $0.5 per unit, and this is nothing but the unit selling price, which is represented as small p. Now the building is leased, so Maxis is paying an amount of $900,000 per year. This is the fixed cost. And for manufacturing the pencils, the cost of raw material, labor, etc. comes to $0.3 per unit. So the variable cost is equal to $0.3 per unit. Now we have to compute the new break-even point in case first the fixed cost is increasing by 10%. So this is increasing by 10%. And second, an increase of 10% in selling price and an increase of $20,000 in fixed cost. So this is increasing by 10% and fixed cost is also increasing by $20,000. So we have to find the impact on the break-even point or the new break-even point in terms of units. Now break-even point is achieved when this part, which contributes to the total revenue, becomes equal to this part, which contributes to the total cost. So this is total revenue and this is total cost, and when both of these become equal, that's when break-even point has been achieved. So let's find out what is the impact on the break-even points with these changes. So the information given to us in this example is that the number of units sold is 5 million per year. The selling price is $0.5 per unit. The fixed cost is $900,000 per year and the variable cost is $0.3 per unit. Now we have to find out the impact on the break-even point if there are changes in this information. So let's first find out the break-even point with this information. Now we know that the break-even point is arrived when the total revenue is equal to the total cost. That means at a point of no profit and no loss. And the total revenue is the quantity at the break-even point multiplied by the unit selling price. Total cost is fixed cost plus the variable cost, which is the multiplication of quantity at break-even point and the unit variable cost. So in this case here, we have the number of units sold, but this is the number of units sold in the whole year. Now we don't know yet whether with these number of units being sold, we have achieved the break-even point or not. And that we'll find by finding this Q as the variable. So Q is the quantity which is needed to be sold in order to achieve the break-even point. So let's substitute the remaining values. So Q multiplied by P, which is the selling price, which is 0.5, is equal to F, which is 900,000, plus Q, which is the variable, multiplied by C, which is 0.3. So let's find this out. So let's move Q on one side. So or Q multiplied by 0.5 minus Q multiplied by 0.3 is equal to 900,000, or 0.2 Q is equal to 900,000, or Q is equal to 900,000 divided by 0.2, which is equal to 4.5 million units. So the company Maxus Manufacturing needs to sell 4.5 million units per year in order to break even, and it is currently selling 5 million per year. So definitely currently with these numbers, Maxus Manufacturing is generating profits as it has already surpassed the break-even point. Now this is 4.5 million units per year. Now we have to find out the impact on this break-even point in case first there is an increase of 10% in the fixed cost. So what this means is that the new fixed cost will be $900,000 multiplied by 1.1. So with this increase in fixed cost, definitely the company will have to sell more units in order to break even. So let's find out the new break-even point. So for break-even, the formula remains the same, which is Q, and in this case we'll put as Q1 multiplied by P is equal to F plus Q1 multiplied by C. So Q1 is the new break-even point multiplied by P, which is 0.5, is equal to F, which is now 900,000 multiplied by 1.1. So 900,000 multiplied by 1.1 plus Q1 multiplied by C, which is 0.3. So or Q1 multiplied by 0.5 minus Q1 multiplied by 0.3 is equal to 990,000, or 0.5 minus 0.3 is 0.2. Q1 is equal to 990,000, or Q1 is equal to 990,000 divided by 0.2, which is equal to 4.95 million units per year. So if the fixed cost increases, of course our cost is increasing, so we have to sell more in order to recover the additional cost. However, we are already selling 5 million units per year. So even if the fixed cost increases by 10%, Maxus Manufacturing is going to continue making profits because it is currently selling more than what would be needed in order to break even. Now the next change that we have to assess is a 10% increase in selling price and a $20,000 increase in fixed cost. So the second change is 10% increase in selling price and $20,000 increase in fixed cost. So here in this case, both side of the equation is increasing. That is, our selling price is also increasing, so we are getting more revenue, and our fixed cost is also increasing. That means we are incurring a higher cost as well. So basically the new selling price will be 0.5 multiplied by 1.1 for a 10% increase, and the fixed cost is going to be an additional of $20,000. So let's now find out the new break-even point. The formula remains the same. So in this case, we'll name the break-even point as Q2 multiplied by P is equal to F plus Q2 multiplied by C, or Q2 is the variable, so Q2 multiplied by P, which is 0.5. However, in this case, it is to be multiplied by 1.1 because there is a 10% increase. So multiplied by 1.1, and this is equal to the fixed cost, which is increased by $20,000. So this becomes $920,000 plus Q2 multiplied by C, which is $0.3 per unit, or 0.55 Q2 is equal to 920,000 plus 0.3 Q2, or 0.55 Q2 minus 0.3 Q2 is equal to 920,000, or 0.25 Q2 is equal to 920,000, or Q2 is equal to 920,000 divided by 0.25, which is equal to 3.68 million units per year. So now break-even point has reduced from 4.5 million to 3.68 million. So basically our profit is increasing because we are already selling 5 million, and to break even we need to sell only 3.68 million.